We're talking about affecting the brain. We're talking about targeting the brain to target individuals, targeting individuals on our end to make them better, targeting individuals who may be competitors, come adversaries, so as to then decrement certain aspects of their thought, emotions, and behaviors, so as to create a tech readiness military advantage on our side.
So when we're looking at this idea of neuroscience and technology for national security, intelligence, and defense, I think the take-home message here is that, yeah, we can access and affect, manipulate and control, so to speak, neural systems to affect, alter, change, direct minds via brains, and therefore the hearts in which those minds are embodied. The more we know about the way people think and tick, the more we may be able to develop those techniques and technologies to alter the way they think and tick.
We can also utilize nanotechnologies, and those nanotechnologies can then create platforms to deliver drugs utilizing electrical and magnetic current to key areas in the brain.
The capability to put vast arrays of sensing and transmitting electrodes deep within the brain in a non-invasive or minimally invasive way to allow real-time access to read from the living brain and write into the living brain remotely.
And here, once again, we're talking about the use of either drugs and or devices to modify the integrity of brain function that we realize can also modify individuals' perception of time and space. We talked earlier about how these may be used in interrogation scenarios, and this too may be used against key individuals to be able to modify their perception of time, their perception of what occurred and what did not, memory modification, etc.
Affect individuals' reality. In other words, if I mess with your data, particularly your neuropsych data, I can really mess with the way people regard you and treat you on a whole host of levels, from the interpersonal all the way to the professional, from the social all the way to security clearances. And if we keep going on the range of technology that's available to us, we then have the use of nanoparticulate agents, aerosolizable nanomaterials that can be breathed in and disrupt blood flow or neurological network activity.
But I can also utilize nanoparticulate matter in a very indiscriminate way. The idea here is that I can get something called high CNS aggregation material that is essentially invisible to the naked eye and even to most scanners because it is so small that it selectively goes through most levels of filter porosity. These are then inhaled either through the nasal mucosa or absorbed through the oral mucosa. They have high CNS affinity. They clump in the brain or in the vasculature, and they create essentially what looks like a hemorrhagic diathesis, in other words, a hemorrhage predisposition or a clot predisposition in the brain. What I've done is I've created a stroking agent, and it's very, very difficult to gain attribution to do that. I can use that on a variety of levels, from the individual to the group, highly disruptive. Most recently, just a few weeks ago, it was announced that you could then aerosolize nanomaterials. And go one step further, I can create small robotic units, controllable robotic units at the nanoscale, and that these too can be aerosolized to create a nanoswarm of biopenetrable materials that you cannot see, that can penetrate all but the most robust biochemical filters, that are able to integrate themselves through a variety of membranes, mucous membranes, and wherever, mouth, nose, ears, eyes, can be then uptaken into the vascular system to create clumping, can affect the vascular system of the brain, or can directly diffuse into the brain space, and these can be weaponized. And they can be done in such a level that their presence is almost impossible to detect, and as such, the attribution becomes exceedingly difficult to demonstrate. Some of these agents allow me to assemble the agent on site and not have to stockpile it, which allows me to take the components of this agent into and out of a country relatively covertly, target a specific individual, change or eliminate that individual with very little attribution and trace, and be able to leave prior to any attribution. We can modify the existing palette of bacteria and viruses through the use of gene editing techniques, very viable. This has been some of my ongoing work with my colleague Diane DeUlis at National Defense University. And what we can also do is recognize that there are existing microbiologicals that can be harnessed to then induce the effects. Moreover, I can create particular neuromicrobiologicals that may have a much longer duration of action, for example, modified Zika virus. And what I can then do is, as a consequence of that, is I can affect subsequent generations to incur a public health morbidity and mortality effect that then creates an increased economic and perhaps social burden. We can also use these techniques that we're learning on the pharmaceutical side to modify certain bugs. And we spoke earlier about a technique that's become very well known, CRISPR-Cas9, that allows us to literally modify bugs in a variety of different ways. So I now may be able to take a relatively harmless microbiological agent, a bacterium or a virus, do some gene editing and make this thing far more morbidly viable, make it far more virulent, and in some cases even make it far more lethal. I can also utilize various forms of electromagnetic radiation and energy to be able to disrupt brain function. The brain is an electromagnetic organ, and like any other electromagnetic substance, the integrity of those networks is reliant upon the electromagnetic pulses that flow in between them. Utilizing electromagnetic sensory and disruptive devices in this way, with ever greater fidelity and with ever greater granularity, can be used as not only an organ against individuals, but against groups. If we keep pushing the envelope a little more, we need not limit neurological modification, engagement, and weaponology to the human frontier. We may recognize also that anything biological can then be weaponized. Here what we're talking about primarily is the idea of weaponized non-human animal drones. I infiltrate that bug's nervous system and I control the way it moves. By controlling the way it moves, I control the way it goes. I control its wings pattern. I control where it hovers, where it flies, where it articulates. And what I can also do is I can then couple this to a very, very small scale set of either biosensors or cameras. And what I basically have here is a biodrone. I can go one step further and I can also impregnate that individual organism, with a very small scale weaponizable delivery mode. In other words, if I'm using a very, very small scale bioweapon, such as a very potent organotoxin, or the delivery of a very small level of microbes that we know can either replicate and infect, or is genetically modified to have a very, very high morbidity effect, I can then utilize this not only as a reconnaissance drone, but also as an infiltrative weaponizable drone that can then deliver some payload to a specifically small and contained group in a very specialized way, or if I use enough of them, an ever-expanding larger group.
As a neurocognitive scientist who's been functionally working in the field for the past 4 decades, I can tell you that neuroscience and neurotechnology are not only under consideration, they are contextually being applied in a variety of national intelligence, security, and defense agendas worldwide.
We've come to the precarious position of opening the proverbial can of worms of if, how, in what ways, to what extent, and when these techniques and technologies will be used in weaponized intelligence and national security agenda. I submit to you, ladies and gentlemen, that can has already been opened. It'll be our job, and increasingly your job, to be able to navigate this new terrain, this brave new world, and what it incurs.